But in our note packages, find where it starts with dividing fractions.
What did he say?
I am trying to put page numbers on the next time so you can find things quickly. Okay? But remember, for studying for your quiz tomorrow, you can use your note package to go through the ideas. Like each of the things that I mentioned, they're listed in here. Right? And if there's ideas that you still don't know, remember you can watch those things on YouTube. So dividing fractions is rewrite all the fractions as improper fractions. Okay, that's our first thing. And flip the second fraction and multiply. So we have a fraction rule that says, first of all, if you just have 2, you can write 2 as a fraction, 2 over 1. And if you have 3/5 divided by 2 over 1, it says flip the second fraction, so instead of 2 over 1, I write 1 over 2. Sometimes you'll hear people saying this. Another word for flipping something is called the reciprocal. That's a hard math word. So and then you change from dividing to multiplying. Oh, I don't know how many years ago it is already that the 1 year, my transitional class, instead of like when we did flip, we called it, see if I can remember how I even spelled it, flipsky doodles. I don't know why.
Who likes chicken? Anybody like chicken? Yes. Do you like KFC?
Nah.
No, me neither. But KFC, KCF. That's how I do it. And I write the K over the first, keep, C, change, flip. I write KCF over
KCF.
each one respectively.
Anyways, this year that we called it Flipsky Doodles, if you search Flipsky Doodles in YouTube, my videos come up. It's like, I don't know if it still does. Should we check?
Yes.
Okay.
Because that would be hilarious.
Let's see if it still shows up.
You gotta make sure you spell it right though.
There we go.
Skidoodles.
Here we go. Let's go YouTube.
Flip skidoodles.
Flip Ski Doodles.
Which is absolutely a math term coined by Mr. Jensen.
There it is. Flipsky Doodles. 10 years ago. I did it 10 years ago.
Unbelievable.
And it's still the first video other than stopping bad behavior. I don't know why that would show up. That's sponsored. This one has, I don't make any money. And you can look at the video from 10 years ago when we did Flipsky Doodles. Still the #1 hit. Oh, I wonder if I mentioned it in, no.
That's absolutely hilarious.
There it is. 10 years ago when we called it Flipsky Doodles. Very fun. All right. Close that down there. So when you are dividing fractions, okay, now we have rules. Fractions have rules for 3 things. Adding and subtracting, the rules are the same. That's on your quiz tomorrow. You can only add pieces that are the same size, so we need that common denominator. Okay? Multiplying fractions is the easiest, because it's just multiply across the tops, multiply across the bottoms, no problem. And you need to know the rule for multiplying, because dividing is very similar to multiplying, except you add this idea of flipping. So, 3/5 times 1/2. Our rule for multiplying is we multiply across the top. 3 times 1 is 3. 5 times 2 is 10. Since we can't reduce this any further, this is our answer in lowest terms. And remember that sometimes you can reduce when you're multiplying early. So if a fraction can reduce, or anything on the top with anything on the bottom, if it can reduce early, it usually makes our life even easier. I like 10 years ago, still #1, Flipsky Doodles. All right, 2/3 divided by 4/5. Change it to multiplying. Keep, change, flip,
KCF.
KCF. Okay. There we go.
Reciprocate 4/5.
Now, you changed it to multiplying. So you have some options here. Because I see something I can simplify. Does anybody else see something you can simplify? Right? The 2 and the 4, something on the top, something on the bottom. Okay? If you see it, that makes your life the easiest. So I see the 2 and the 4, and I can say I can divide those both by 2, leaving me with 1 here and 2 here. Because 2 over 4 is the same as 1 over 2. So if you find something you can divide them both by, and you do that early, that will make your life the easiest. Because now you have 1 times 5 across the tops. And on the bottom you have 3 times 2. This is already in lowest terms. I'm going to put or here. Okay? Because someone's bound to say, well, what if I didn't see it? Is it wrong? No. But your numbers get bigger. Okay? Now, if I multiplied across the top, I would get 2 times 5, I would get 10. And on the bottom, I'd have 3 times 4, which is 12. And that's not a wrong answer, but it's not in lowest terms yet. Because what can you divide both 10 and 12 by? You can divide them both by 2. So if I divide them both by 2, this becomes 5 and this becomes 6. You get the same answer. And this one I don't think is bad either way. None of the numbers got really, really big. But sometimes if you don't seek to simplify early, your numbers get a lot bigger and a lot trickier as a result. I noticed with your times table, guys, you guys were amazing up to 5. Then when we got to 8, right, 6, 7, 8, and 9, that's like, like a little bit of hesitation, right? Some of those ones like 8 times 7. See, still the hesitation. What's 56. Good. 7 times 9.
Crickets.
63. Those ones take you longer, right? Or if I did 3 times 3? Oh yeah. Right? You've got those smaller ones really good. We got to work on some of those bigger ones. So if you can simplify early, that can mean that your life is often easier. This one worked out to be about the same. 5 divided 5 over 6, so we keep that one. Change it to multiplying and flip the other one. Okay? Now you have a negative here. We can keep the negative out in front, or you can decide to put the negative either on the top or the bottom. So I want to just point out here that if you had a fraction that was this is equal to that is also equal, you can choose where you put the negative. But you can only have one negative in there, no matter which way you decide to put it. Okay? Anybody see anything they can simplify? Either right above each other or anything with one thing on the top and one on the bottom. 5 divided by 5 is 1. So I can take those, they both divide by 5 and change them to 1s. Anything else? What about the other diagonal? Yes, what can they both be divided by?
3.
You can divide both by 3. I'm going to do that in a different color. Okay, this, if you divide it by 3, you'd be left with negative 3. And divide this one by 3, you're left with 2. So now, the numbers I'm left with. On the top, I'm left with 1 times a negative 3,
3. Negative.
negative 3. On the bottom, I have 2 times 1, 2. Perfect. Okay, but notice I did it with colors, and notice I tried to be really neat. Because if you start doing it really fast and are a little bit messy, you might lose where your numbers are. So sometimes it's not bad, okay? But now I'm going to test your times table. What's 9 times 5? 45. And because it's a negative, I would get negative 45. What's 6 times 5? 30. And now, this is where I think it's a little tricky.
I love it. You're like, I'm the fastest. That's what you're thinking.
What can you divide both 45 and 30 by?
3.
You can divide them both by 3. What would you get? You can divide them both by 5.
What
Good.
about higher than that?
If you can divide them both by 3 and you can divide them both by 5, any guesses what else you could divide them both by? Not 8, but not 9. Put these together.
8.
3 and 5. You can divide by 3 and you can divide by 5. You can divide by 15. 3 times 5. But who said, which was the first number we said? 3? Okay, what do you get when you divide 45 by 3?
Like 17 or something, I don't know.
No. Not 17. Keep trying. Divide 45 by 3. $15. Okay? I just want to point out that there you guys had some hesitation there, right? That's harder. What do you, 30 divided by 3, I think you get that one pretty quick. 10. Good. Now we have negative 15 and 10. What else can you divide by? Those ones by. 5. Which is makes sense because you said 5 at the beginning. What happens when you take 15 divided by 5? 3. And 10 divided by 5?
2.
Same answer. But if you simplify early, do you see how much easier it is? Right? And you have smaller numbers to work with. So not a bad thing to do. You have a whole number, write it as a fraction. It's going to be 6 over 1.
Where do you have to flip that?
Which one do we flip? Keep times, and change that to multiply, and then flip. That's the one we flip. Anything you can simplify. The 6 and the 4. The line, what can you divide them both by? 2. So 6 divided by 2 is 3. 4 divided by 2? 2. Okay. Anything else? If there's nothing else, then we'll go to multiply. Now on the top I have 3 times 5. 15. All right, let's see who's the fastest. 1 times 2. 1 times 2. 15 over 2.
Who's the fastest? What is that as a mixed fraction?
Oh, mixed fraction. And 7 and 1 over 2. Right? If you have $15 and you split it between 2 people, does it make sense that they get $7.50? Right? $15 divided by 2 people, $7.50. So what is that $7.50? That's a decimal, right? Someone said mixed fraction 7.5. Decimal would be 7 point. Okay. Big breath. You ready for the next level?
Yes.
We'll add the mixed numbers.
Bom, bom, bom.
So just like before, first of all, we want to take that and write as improper fractions. So 7 and a third. You remember how to change that to 7/3, right? The thirds means you have a whole thing that's divided into 3 pieces. So if you have two whole chocolate bars and a third of a chocolate bar, those 2 whole chocolate bars would have 6 pieces then, right? Each chocolate bar has 3 pieces. So 2 times 3, this is how people do it, right? They go 2 times 3, that's telling you have 6 full pieces with those 2. Plus 1 other piece gives you 7 pieces. These chocolate bars were split into 4. You have 3 full chocolate bars. 3 times 4 would be
two of them?
Well, what's 3 times 4? 12. Plus 3 more pieces gives you the 15. Okay?
Everybody good?
Alright. Mr. Shark's got that under control.
No. What was happening?
Well, looked like it was a little bit of a heated argument out there.
I think so. Wait, so would you just do that?
Here,
the same
we can add to the video.
Wait, would you do 3 times 4 and add the 2 and then just do 7 over 3 times and then flip the other number?
So keep this one, change the sign, and then flip this one. Is there anything you can simplify? Anything that divides
Oh, yeah,
something
that
on the top
cross,
and
yeah.
bottom? You don't see anything, right? It looks like you should, right? But 7 and the 3? No.
Nope.
4 and the 15?
Nope.
No. 7 and the 15?
Nope.
And 4 and 3? No. So when we practice our times table, what is 7 times 4?
28.
28. Awesome. 3 15s?
45.
45. And what's really cool is if you couldn't simplify early,
That means you can't have.
you can't simplify after, and it saves you time checking. Because I'm guessing if I said, hey, what divides both 28 and 45? There would be crickets in here, quiet, and everybody'd be thinking. And no one would come up with anything. But no one would be confident enough to say there isn't anything. Especially if I waited, like, come on, guys. I'd give you, I could totally convince you that there was something, and you try and you try and you try. I'm just kidding. Nothing simplifies. So we are done on that one right there. Hey.
It's literally the same thing except with some brackets and
Right.
minus.
Yeah, and we got the brackets. We got. So what's 2 times 5?
10.
10 plus 1 more,
11.
11, and it's going to be negative. I'm going to keep the divide sign for now because we're going to change these into improper fractions first. Now 2 times 7
14.
plus 3,
19.
and this one's negative, so I'm going to put the negative up there,
Would you flip it?
right? Keep, change, flip. So we keep this one. KFC spelled wrong. Change the sign in the middle to multiply. Flip the last one. Can anything simplify? 11 and a 5?
No.
No. 7 and 17? No. 11 and 17?
No.
And 7 and 5? No. So we have to multiply big numbers.
77 over.
Okay, 11 times 7?
77.
77. Do you see that you have a negative times another negative? What's that going to make it? Negative or positive? Negative times a negative. This will become positive. 5 times 17.
What?
5 times 7, 5 times 17.
85.
85. How did you do it?
I did 5 times 7, and then I got 35.
And then?
And then I did 5 times 1, which is 5, and then added 3.
Okay. You did 5 times 1, and that you put them over top of each
Yeah,
other?
yeah, yeah.
Would you agree that 17 is 10 plus 7?
What
Yeah.
the?
So if you do them separately, 5 tens is 50, 5 sevens is 35, 5 17s is just added together 85. You can really see this, right? Do you know how I was telling you the other day that one way that we can talk about multiplying is by thinking of areas. So I'm going to draw a rectangle. That's 5 by 17. But I'm going to break the 17 up and with 10 and 7. That makes two new rectangles. This rectangle is 5 times 10. That one's 50. This rectangle here, there's still 5 here, is 5 times 7. It's 35. Does it make sense that my 5 times 17 rectangle would be 85? It's kind of cool. So whenever you're multiplying bigger numbers, you can break it up. You can draw a rectangle and break it up into super easy things. In fact, oh my goodness. How crazy do you guys want to be right now? A little bit crazy? You want to do 23 times 37? Mental math, do you think you're good at that? Probably not right now, right?
Wait, what is it?
23 times 37.
20 times 30.
I'm going to make a rectangle. I'm going to make this side 23 and this side 37. I'm not good at 23 times 37. Are you good at your 23 times table? No, probably not. Especially not up to 37. I'm going to break up 23 into easier numbers. Maybe I know my 10 times table. You can break it up as much as you want, but I'm going to go 10, 10, and 3. This is 10, this is 10, and this is 3. Okay? Maybe you can do these. Do you know what 10 times 37 is? You know the trick for timesing by 10? Just add the 0 onto the other number. So you could say, I know this one's 370. I know this one's 370.
And 30.
And then this one's 3 times 37. That might be hard, right? So maybe you want to, how would you like to break up the 37? Do you think you could do 3 times 30 easily? So you could break this one up to 30 and 7. Make two new rectangles.
So it'd be
3 times 30 is
3 times 30, 90.
90. 3 times 7,
Maybe 100 and
that would be 21. So 23
111.
times 37 is going to be adding up all of these. 370 plus 370 plus 90 plus 21.
851.
851. That work out? Very, very cool. So if you just know your 10 times table, you can always break things up into smaller and smaller things. I mean, you could make 23 ones along here and 37 ones along there and make a whole bunch of little rectangles that were 1 by 1, which would all have an area of 1. And then you just have 851 little ones to add up in the end. You could do that. But I think sometimes you can break it up and be more efficient. Anyways. We didn't finish our fraction. We figured out this was 85. Circle that final answer. Because you can't simplify it because we simplified it early and checked. It's another really nice thing about looking early to see if you can simplify something. How many more do we got? One more. 2 3/5. Again, I'm going to change these to improper fractions first. Okay? 2 full chocolate bars that were split into pieces of 5. That would be 10 pieces. Plus the 3 more? 13. 4 full chocolate bars with 2 pieces each. That would be 8 pieces. Plus 1 more.
What do we flip that?
Now we've changed it to improper. Now we have to keep, change, flip. Flip ski doodles or whatever you can do to remember. We keep the first one the same. We change the sign to multiply. And then we flip. Check all your numbers. Anything simplify?
Nope.
No. You get pretty quick at that. Check top and bottom here, top and bottom there, diagonal here, diagonal here. Nothing simplifies. Is my answer going to be positive or negative?
Negative.
It's going to be negative. Sometimes I just look and say positive number times negative. I put that negative right at the beginning because it can be in front of the fraction, it can be in the top of the fraction, or it can be in the bottom. 2 13s.
26.
26.
Over 45.
5 9s, 45. And because we checked early, we can circle that final answer. It's already simplified. So flip ski doodles, keep, change, flip. It's still going. It's impressive. Okay,
Right up to the mushroom.
once you've done a few questions, I'm going to give you something to work on. Were you here the other day